Hi guys, welcome back. So we have seen the conditional probability, and in this video we'll be looking at chain rule, and then we'll be trying to see how this chain rule is connected with the concept that is known as inference net, and then how it is connected to the naive Bayes machine learning algorithm. I know the videos are getting bigger and you are just waiting for the conclusion. You want to know how these things are connected to naive classifier. So let's first of all see again briefly what is conditional probability. So I have created here two sets are there, set A and set B. They represent type of events, and there is this space here. Okay, so if I want to find out the probability of A provided that B has already happened, then it will be something like we have already studied, something like probability of something divided by probability of something. So as I have already marked these reasons, so we can just get these reasons. So probability of A provided B has already happened will be probability of the reason that is marked like this, and then there will be probability in the denominator. The probability will be this. Okay, and this actually means that the probability of A intersection B at the numerator and probability of B. Okay, and this intersection we will use this notation of A comma B. Okay, so it will be probability of A comma B divided by probability of B. Okay, so this is it. This is how we define the conditional probability, and we already are familiar with the Bayes theorem. In the previous video we have seen the Bayes theorem. Okay, so we are not going to discuss about it, but let me just shuffle the equation a bit, and from this relationship we know that probability of A and B will be equals to probability of A provided B has already happened multiplied by probability of B. Okay, so this is it. This is for two sets. What if we have another set, a third set here? Okay, and this is C. Then what will be the probability for A comma B comma C? That is the probability of A and B and C. So this we want to consider. Okay, so let's suppose we can just assume that let's E is equals to B and C. So E is an event that is defined by events B and C. So whenever B and C happen together, this we denote as the event E. Okay, so this can be written as probability of A comma B comma C, can be written as probability of A and E, and this by this equation here we can write it like probability of A provided E has happened and probability of E. But we know that E is nothing but B and C, so it will become B and C and probability of B and C, and this further can be replaced by using the same equation as probability of A provided B and C has happened multiplied by the probability of B provided C has happened and then multiplied by the probability of C. So you can see there is a general relationship. You can see this first term, you can see this first term is coming here, and then rest of the variables after this first term are coming after this bar here. And in the second term, when this is coming at here, the element that are coming after B are coming to this side of the bar, and then the single element. So we can just generalize it, or just you can try it for probability of A, B, C, D by just assuming the things, and you'll get the similar kind of thing. So now we are at the position where we can define the chain rule. So chain rule is nothing but just a generalization of the same concept that we have seen here. So probability of x1, x2, probability of all these events to happen together, all these xn events to happen together will be the product of probability xi provided that xi plus 1 to xn has happened. Okay, so this is just a general thing. So this is what we call chain rule basically. Okay, so this equation here came from this thing. In the next video we'll be looking into the independence and dependence of these variables here, and how these things are used in Bayes classifier. So keep watching, subscribe to this channel so that you can understand the machine learning in a better way. Thank you for watching.